Okay, section 4.6, and this actually doesn't bring a close to chapter 4 just yet, but it does bring a close to our cumulative list here that we've kind of been accumulating of different techniques and strategies for how to solve quadratic equations. We've talked about the graphing method, which was essentially all on the calculator, finding the x-intercepts, the factoring method, the square root property, recently completing the square method, and then we're going to add a method that I think is relatively familiar to you, and that's the quadratic formula. Okay, the quadratic formula is a formula that you should make sure that you commit this to memory. You would be expected to make sure that you're completing these problems similar to how you're going to see me demonstrate here today on the notes. If you happen to have the quadratic formula program on your calculator, that is something that would not be a permissible way to doing these problems. I need to see some of these substitutions. Also, when the value underneath the radical symbol is not a perfect square, of course the quadratic formula program would just report a couple of decimals. They would have report the decimal values, and I want you to leave it with the radical over top of the number. Okay. So let's go ahead and take a look at a couple of these problems here. I think the key is you've got to make sure that you properly identify the value of A, the value of B, and the value of C, because those are all used in the quadratic formula. Okay, so in this particular problem, and things have to be in descending order, the A value would be a 1, the B value would be an 8, and the C value would be a 16. Okay. A common mistake that people make is they don't put this division or fraction bar across everything in the top. Sometimes they only put it underneath this part where the radical is. It goes underneath everything. Okay. Then it says negative b plus or minus the square root of b squared minus 4 times a times c, and that's all over 2a. Okay, so I want to see that initial substitution right there, and then I would like to see you simplify each of the three sections. Okay, section 1 being this value here, section 2 being what number you would get underneath the radical, and then the third section being what's in the denominator. So it looks like we're getting negative 8 plus or minus. If you were to type in 8 squared minus 4 times 1 times 16, I believe that you end up getting a 0 underneath the radical symbol and a 2 in the bottom. So we know this, that the square root of 0 is 0. So this plus or minus is what often produces two possible answers to these quadratic equations, because you go through the problem once, negative 8 plus 0, divide by 2. That would give us an answer of negative 4. If I go through the problem a second time with subtraction, negative 8 minus 0, divide by 2, I'm still getting negative 4. So I only have one solution. This probably, if we were to use the graphing method, this would be, something along the lines where it's just hitting the x-axis right at the vertex, and so that's why we're only getting one solution instead of two. Okay, I worked through example B for you. I am okay if you stop right here with what I have in this black box here. If you were to continue on and simplify, what I was doing there is I was taking the 92, I broke it down into prime numbers, and then there was a pair of identical factors, so I used those two 2's to be able to pull a 2 out in front. And then only with these numbers that were outside of radicals, if I can reduce something from all three of those, which there's a 2 in all of those, I cut negative 6 down to negative 3, I cut 4 in half down to 2, and I cut 2 in half down to 1, and just there's a 1 in front there. Okay, but it is acceptable if you just have the answer like this. Okay, I do not want you to have as your answer, though, decimals. Okay. All right, so let's go ahead and try this one here. It looks like everything has to be all moved to one side first before we can properly identify the A, B, and C values. Okay, so we're going to bring that negative 10 over. That means our A is 1, our B is negative 6, and our C is positive 10. Okay, again, we're going to set up negative B, so we got a double negative there, plus or minus the square root of b squared minus 4 times a times c, and that is all over 2 times a. Okay, we're going to simplify each of these 3 sections. Okay, so we're getting positive 6 plus or minus, okay, very important here that you're using parentheses. This negative 6 squared should become a positive 36, not a negative 36. Okay, minus 4 times 1 times 10, I believe, gives you a value of negative 4 underneath the radical with a 2 in the denominator. Okay, now let's look closely. 4 is actually a perfect square. We know that when we take the square root of 4, we get a 2. Okay, we've also learned with imaginary numbers and complex numbers that when you have a negative underneath a square root symbol, you should always express that as an I out in front. So this problem is going to be 6 plus or minus, I'm going to put a 2 there for the square root of 4. I'm going to put an I there for representing the square root of negative 1. And then I'm going to do similar to what I described here where we reduced this 6, this 2, and this 2. If you can take something out of all 3 of those, then you can reduce this. Well, we can take a 2 out of everything. So the 6 becomes a 3. The 2 in front of the I becomes a 1, and the 2 in the denominator becomes a 1. So we can just write the answer 3 plus or minus I. Okay? All right, that is how you simplify using the quadratic formula. The section in the quadratic formula that is underneath the square root symbol has a specific name. It is called the discriminant. Okay, so the discriminant is only the number underneath the square root symbol. I'm going to circle that in pink in each of these above answers. The discriminant was a 0 in the first example. It was initially a 92 in that example, and it was a negative 4 in that example. Now, what is the benefit of just knowing the discriminant? Because if you only know the discriminant, that's not enough to tell you what the full solution is. But here's what the discriminant will tell you. It will tell you how many solutions you can expect to get. Okay, and your options are you're either getting 2 solutions or 1 solution. Okay, and then it will also tell you whether those solutions are going to be real numbers or whether they're imaginary numbers. For example, let's just look at this one here. Anytime your discriminant is a 0, that is the situation where you're only going to get 1 answer, because when you go through this problem twice and you add a 0 and then go back and subtract a 0, it doesn't produce a second answer that's different than the first one. Okay, so anytime your discriminant is a 0, you're going to get 1 solution, and that 1 solution is going to be a real number. Okay, real numbers are numbers that do not have negatives underneath the square root symbol. So what this chart is saying at the bottom, and I'm kind of in the middle row here, I'm going to abbreviate, if your discriminant is equal to 0, okay, if it equals 0, oops, I put that in the wrong spot here. Not in the middle row, I want to slide that down here. Okay, if your discriminant equals 0, don't worry about rational or irrational with these things. You're going to get 1 real number solution or root. Okay, and you can see graphically, here's what that would look like. Your graph would have only 1 x-intercept to your parabola. Okay, now let's look back up here. If your discriminant, remember that's just the number underneath the square root, the b squared minus 4ac, if that is a positive number, okay, so if it is a number greater than 0, okay, if the discriminant is positive, then you're going to now have 2 solutions, and those 2 solutions are going to be real numbers because this wasn't a negative number underneath the square root. Okay, lastly, if your discriminant is a negative number, okay, and that's what we're talking about here, if your discriminant is negative or less than 0, that is when you're going to get 2 solutions, but your two solutions are going to be complex, or we could call them, they're going to be imaginary. Okay, and that is, if you look at what our answer was up here for this third example that we just did here, notice how we had an I in our answer, and there's two answers here. 3 plus I is one, 3 minus I is the other. So two solutions, but they're both imaginary because they have I's in them. But what I want to draw your attention to is how the graph looks when your solutions are imaginary. The graph doesn't show any x-intercepts. Okay? Now, in the past, before we learned about imaginary numbers, if our graph looked like this, then we would just say, oh, there's no solution. Okay? Well, technically, there are two solutions. There aren't any real number solutions, but there are two imaginary solutions. Okay? So from now on, when you're doing the graphing method, if your parabola would look like this and have no x-intercepts, you would need to write down no real number solutions, and then to get the two imaginary solutions, you would need to pick a different method, such as the quadratic formula. Okay? All right, so let's take a look at a few discriminant problems here. Okay, we'll go ahead and take a look at, I did one of them for you. This is simply asking you to just find the value of just the discriminant. Okay, and then once you've calculated the discriminant, they want you to say how many solutions, 0, 1, 2, or what's the type of solution that you would expect to get. Actually, there'd be 0 real number solutions, but that means there's 2 imaginary. So let's just take a look here. All right. So I've got this. It's in descending order. Everything is all to one side. That's great. I'm going to identify the A, B, and C. I'm not doing the full-blown quadratic formula. This problem's just asking for the discriminant, so I'm only doing b squared minus 4ac. Okay, when I work through that, it looks like I'm going to get, as my answer, I'm just going to abbreviate discrim. That's going to equal the number negative 19. Okay, now, what does that tell me about my solutions if I were to do the full quadratic formula? Well, if my discriminant is negative, then I know that I'm going to be getting 2 imaginary roots, or you could say 2 imaginary solutions. It's also acceptable if you want to say you're going to have 2 complex roots. Okay, that's the same thing there. I don't know exactly what those solutions are unless I do the whole quadratic formula, but the discriminant at least tells me how many and which type it's going to be. Okay, let's try one other one here. This is not in descending order. Please be especially careful. If you just hop into this quickly and you don't look, you might inadvertently mistake the A and the B values or accidentally exchange those. Okay, make sure you've got it in descending order. Again, not the full-blown quadratic formula here. This is just asking us to do the discriminant. Notice how I'm showing my substitutions. This is what I would want you to show as well on your homework. Okay, and then if we type that into the calculator, it looks like we're getting for the discriminant the number 289. Okay, 289. So if 289 is the discriminant, that means the number underneath the square root symbol was a positive 289. So if it's positive, I should be getting 2 real roots. You don't need to concern yourself with distinguishing between whether the roots are rational or irrational here at this point. Okay, that actually brings a close to all the methods we've been discussing. This chart down here is something you want to be familiar with. You know, each method comes with its own set of advantages and disadvantages. I want to talk through just filling in a few of these blanks here with you. But you'll notice these are kind of grouped together in sort of 3 sections, okay? Graphing is kind of by itself here, okay? If we were going to say, look, what is the advantage of the graphing method? We're going to say, look, the graphing method is easy. I mean, you're doing most of the work on your calculator. It's easy as long as you can find a window to see the x-intercepts. Okay, it's very easy. So what would be a disadvantage of the graphing method? Well, there are 2. The answers are approximate. They're not exact, okay, unless your x-intercept was exactly at like 4 or -1. But if it's at some weird decimal, then there's no way for you to take that big long decimal you're seeing on your screen and switch it like back into a fraction or something like that to get the exact answer. You're forced to round it. Okay, the other disadvantage of the graphing method is if there happens to be no x-intercepts, and this is what I was just mentioning on the front of this notes page, then you have to choose a different method in order to find what the two imaginary solutions are. Okay, so I'm talking about if you were to graph and then the graph looked like this, you couldn't just say no solution and that's it. You'd have to say, oh no, this means that there are two imaginary solutions, and then pick a different method. Completing the square, quadratic formula, something like that, in order to reveal the two imaginary solutions. Okay, I've lumped together factoring and square root property together because they kind of share the same advantages and disadvantages. In terms of these two methods, they can be some of the easiest methods to use depending on the way the problem's set up. I mean, gee, if you had something like this, that's super easy to just difference of two squares and we get that the answer is -7, +7. Or, for that matter, if it was set like this, super easy to just do the square root property and get +7, -7. Okay, so they can be the easy, depending on what's given to you. The disadvantage is that not all problems can be solved using those two methods. There's some problems that you can't factor it, like you get to the X puzzle and there isn't something that would work. That usually is an indication that your solutions are imaginary and you want to dip down to trying one of these two. Also, the square root property. Here's where the square root property wouldn't work. Okay, it's not going to work if you have a trinomial, okay? Then the square root property will not work for something like that because you have two terms that have x's, and this method is telling you that you're supposed to get by itself the term that's squared. Well, you don't want to, in the process of doing that, you don't want to be moving one of the variables to the other side. And so this is limited to like problems where there's just an x squared but no other x somewhere else in the equation. Okay, lastly, I've lumped together completing the square and the quadratic formula, again, because they share the same advantages and disadvantages. Here's the advantage of these two. Every single problem, all the problems can be solved using these two methods. And the other advantage is these two methods will always give you an exact answer, okay? Meaning you're not forced to round it. You're going to have that radical symbol, so if the number underneath your radical symbol is not a perfect square, you can kind of keep the whole answer intact, and you're not forced to round the answer like the graphing method kind of forces you to do. Disadvantage of completing the square and quadratic formula, these methods are intricate, so there are many places that you can make mistakes, okay?